So, our planet is about 4.5 billion years old, give or take, and it has a history of doing shadowy things, such as creating landmasses and then making them disappear. Around 1 billion years ago, I wasn't around then, a mysterious supercontinent was formed, and it swallowed and flipped the mainland inside out. And that could happen again quite soon, in geological time. The historical period when the land connected to become the Rodinia supercontinent and the time frame it split are a bit foggy. Geologists believe that roughly every 600 million years, we are met with the same fate. Our continents connect to form a huge landmass, our oceans connect to form a superocean, and then they split. The first supercontinent ever was Nuna. It appeared about 2 billion years ago and broke apart roughly 1 billion years later. Then, after some more million years, Rodinia, roughly translated as birth giver, appeared. It collected most of the Earth's land masses and then split around 750 million years ago. Now this is our mysterious supercontinent. So, from what you understand, this dance between continents happens at a snail's pace. Even the longest living animals on Earth that can live up to 400 years, like the Greenland shark, won't be able to experience this reorganization. Would you like to see any of the supercontinents if you had such a chance though? Let me know in the comments. There isn't much information about the position where Rodinia formed, but geologists are constantly finding new clues on its original location around the globe. As the time went on, Rodinia began to split, but that happened in stages. The breakup was triggered by a superplume. Huge rising jets of hot molten rock in the Earth's mantle began expanding. That caused enormous volcanic eruptions that were later found in every continent. After the initial split, another sea appeared 200 million years later. It became the famous Lapidus superocean, and it stuck around until 400 million years ago. It formed in the southern hemisphere of our globe around 3 ancient continents. There was Laurentia, Avalonia, and Baltica. But history was once again repeating itself. So the ocean vanished, and the lands merged again to form a new great supercontinent called Pannonia. Now, Rodinia stood out for a ton of reasons. One of them was because the landmass was barren. It couldn't produce vegetation, and it was overall lifeless. No trees or plants were around. It appeared during a time when life on dry land didn't even exist. That's when the ozone layer comes into play. The ozone shield started forming a little after the Rodinian continent appeared. Sunlight hit the oxygen molecules and broke them into smaller individual atoms. Interestingly, the ozone layer, unlike oxygen and oxygen gas, consists of 3 oxygen atoms, and it appears as O3. Since its appearance, it began absorbing higher levels of radiation from the sun, and that allowed life on land to flourish. Before the ozone layer, the only living things could be found in the ocean. They were blue-green algae. But after the protective shield formed, small creatures appear, life grew, and evolution thrived. When Rodinia started welcoming new tiny beings, it also started to separate, and new oceans were born. The seafloor started spreading, and that resulted into warmer oceanic lithospheres. Now, those lithospheres had low density, and when they warmed up, they couldn't dive as deep as the cooler ones did. So here's where it gets interesting. A study led by Xing Li from Curtin University in Australia found some unique patterns about the supercontinent cycle and the Earth's lithosphere. They found patterns in the mantle that matched perfectly to a 600 million-year-old cycle. According to one of the papers, Li and his team believe that the Earth has 2 alternating cycles. The first one runs for 600 million years, and it brings all the landmasses together. The second cycle lasts for double the time, around 1.2 billion years, and a new superocean is born. Each of these events has 2 shifting methods: introversion and extroversion. No, I'm not talking about psychology, these are geologic terms. So let's start with the first one, introversion. Now imagine a giant landmass being surrounded by a superocean. When the continent starts to separate and small rifts form, water begins to slowly flow through them until a smaller inner ocean is formed. That's when subduction zones come into play. These are the boundaries that mark the collision between tectonic plates. Now, dropping all the sciencey stuff, here's what I mean. When tectonic plates meet at a subduction zone, one bends and then slides under the other. Then they both slowly curve down into the mantle. Wow, that's some subduction going on, all right. Now, tectonic plates can either be both oceanic and continental, or they can be one of each type. For example, the oceanic crust is denser than the continental. So, at a subduction zone, the oceanic crust will be the one to sink below the lighter continental crust. Sometimes there could be a collision between two continents, so the plates crash together without a subduction zone forming. That's exactly what happened when India slammed into Asia millions of years ago, and the Himalayan chains formed. Now that we got the gist of what subduction zones are, let's get back into the juicy methods the Earth uses to make things disappear. During the introversion method, the oceanic crust dives back into the Earth's hot mantle. The inner ocean sinks back into the Earth's interior, and then the continents reconnect again. So, a new supercontinent gets formed with the same old water that existed before. But extroversion is quite different. That method creates a new superocean and a fresh landmass. Let me show you. At first, the supercontinent starts to separate, so water begins to flow through it and an internal ocean is formed. But the subduction zone doesn't appear there. It shows up in the superocean around the separating landmass. Then, the Earth swallows the superocean while also pulling apart the rifting continental crust, which begins to sink at the bottom. So, the landmass literally flips inside out. The coastlines collide again to form new centers, and the middle of the old continent becomes the new coast. Lee and his research team created a simulation to study that pattern, and they found that in the last 100 million years, both extroversion and introversion changed. If the pattern continued, we'd be due a new extroversion method in a few 100 million years, yet we are due to another introversion. Let's go back to the Nuna supercontinent that I told you about at the beginning. When that happened, it occurred through introversion. Both Nuna and Rodinia had the same superocean surrounding them. That ocean was called the Miravoi. When the oceanic crust started to subduct, Rodinia began separating and the sea disappeared. Interestingly, that superocean reappeared as the Panthalassa in the formation of Pangaea. After Pangaea broke apart, Panthalassa appeared, which means the whole ocean survived in the Pacific's ocean crust. Since the patterns have changed, it's estimated that the next supercontinent will be created through introversion again. The Indian, Southern Oceans, and possibly the Atlantic will disappear. The Pacific will expand again, and a superocean will be born. This future hypothetical supercontinent is given the name of Amasia. It got the title from the idea that Asia will merge with North America. The theory relied on the fact that the Pacific crust is subducting under Eurasia and North America. Another clue is that the western part of the Pacific Plate is subducting under the Philippine Sea, which created the Mariana Trench, the deepest part of the Pacific Ocean. But this is just a theory. Some models tried to follow the movements of our continents to see if an extroversion or introversion is possible. Lee and his colleagues researched the molecular variation patterns in ancient rocks and found that introversion is most likely to happen. Everything comes down to plate tectonics. The problem is, nobody knows what causes the beginning of a subduction. There is even disagreement among geologists on when the Earth plates started moving around. Some of them say it started a few million years after the Earth was formed, while others claim it started 2 to 3 billion years later. But at least now, we were able to understand how the Earth can flip its continents inside out and that it won't probably happen when a new landmass forms. Right now, the tectonic plates are moving north, which includes Australia and Africa. It is estimated that in a few 100 million years, I won't be around then, all the landmasses excluding Antarctica will connect in the North Pole to form the Amasia. That makes everyone wonder how we will evolve, what the climate of the supercontinent will be like, and how life will adapt. But I'll leave that to the scientists. Or my fortune teller. Hey, if you learned something new today, then give the video a like and share it with a friend. And here are some other cool videos I think you'll enjoy. Just click to the left or right, and remember, stay on the bright side of life.